G'day, my name's Stuart, and today I'm going to try and explain how to represent a sine wave as both a polar and a rectangular format. So in general, the basic mathematical format for a sine wave is given as a sine omega t plus or minus theta, where a is the amplitude of the wave, omega is the period, crest to crest, and omega is the spacing of that wave across the horizontal axis. So this is useful when identifying and graphing sine waves. However, when it comes to AC circuit analysis, we must be able to represent the sinusoidal waveform as both a magnitude and a direction, which is polar format. Similarly, we must also be able to represent it as a complex number, a plus or minus bj, which is known as rectangular format. So looking at the pictured waveform, we have 50 sine t plus 30 degrees. To change this into polar format, all we need to do is look at these two values here, the amplitude and the phase angle. But we need to change this amplitude into an RMS value, which is simply done by dividing by root 2. And this gives us a value of 35.4 with a phase angle of 30 degrees. And that is our polar format. To convert to rectangular, we first need to get our polar format, which we've just done. And what we do next is we either use a little bit of mathematics or we can punch these numbers straight into our calculator. So mathematically, what we do is we multiply the magnitude 35.4 by the cosine of the phase angle, and that gives us 30.6. Similarly, we then multiply the magnitude by the sine of the phase angle, which equals 17.7. Putting this into the rectangular format or the complex number format, we then get 30.6 plus or minus, plus 17.7j. And that is our rectangular format. I hope this has been helpful.